First talk is going to be about Bevy and its entity component system by Trent. Please welcome.
Hello, I'm Trent. Can I get a raise of hands, anyone who's interacted or looked at Bevy or an ECS before? Okay, that's pretty good. That's a good thing. Hey, you get two. All right, cool, let's go. So if you haven't looked, ECS is sort of a tool or a framework for architecting data-oriented applications or applications that have to process or simulate a lot of data frequently. And Bevy ECS is one flavor of that. It's a purpose-built framework for a particular game engine. It focuses on ergonomics, speed, and parallelization, and it's incredibly active repository and project. It's had almost 1,000 contributors, and when I looked yesterday, it had about 100 unique contributors in the last month, which is pretty big. And these are some of the games that are in development or already released with Bevy. And they sort of span a mix of completely in Bevy, 100%, and just using the ECS or using parts of Bevy but swapping them out for others. That's one of the big strengths of Bevy is how modular it is. You can just swap things in and out, and I'll touch on that a bit more later. And these are some of the experiments that I've done, some like toy car physics, some city builder stuff, and the space thing. You can ask me about it later. Cool, so entity component systems. Let's start with those three. So what's an entity? It's really just a unique identifier. If you think about a database, it's a primary key. You can think of it like that. And not really much else. It doesn't have any data in it. However, that's where components come in. So components are sort of atomic units of data you can associate with an entity. So entity by default has no data, but you can associate different components with an entity. And systems, ECS, the system. System is really just a function that runs over the data to do some kind of transformation or query or aggregation or whatever it may be. And it can help to think about entities in sort of like a table like this. So an entity is really sort of this primary key that can be associated with multiple components or no components or some of the components. And however, under the hood, it's a little bit more clever than this. How it actually organizes it is every entity that has the same set of components is sort of grouped together. And they're stored in what's called archetypes. So every entity that has a name, a current score, and a high score component will be grouped sort of together. And under the hood, it's basically 4 vecs of just entity, name, current score, and high score. And then if an entity has a different shape of components, it'll be in a different archetype. And so this massively speeds up querying because instead of asking every entity, hey, do you have this component, do you have that component, you can just ask the archetype and then you know everything in there is safe to query. So let's do some examples. This is an example of a system that is querying all of the current score components, and it's going to call some random and change the score of the components depending on the result. So there's really just regular Rust code here, right? We're not like involving any special systems or anything. We just have this sort of query type at the top that is really doing a lot of the heavy lifting for us. And we just mutate the elements in that query as we see fit. Next, we're going to go through all of the scores, and we're going to update the high score. If the score last time got incremented and it's now higher than that high score, we're going to add it up. And we have one addition to this query here. So in the first line, we're now requesting 2 components at a time. So this will only match on those archetypes that have both. And we're also, the line under, we can supply a filter. And so we're only wanting to get all the current scores that have changed since the last time the system ran. So the systems will keep track of what's changed and what hasn't. And then again, the Rust code is very vanilla. And lastly, we just query everything, the high score, and the names, and we just print them out at the end. And queries under the hood do a lot of fancy tricks to aggregate all of the data between archetypes and present it to you in a nice interface. And you get a Rust iterator out of it. You can do all of your usual Rust iterator shenanigans that you love, all the same, and under the hood, it's all managed for you. So that's a basic example. And this is how you would sort of plumb those things in. You create a world, and that world holds your data, and you can spawn some things in. So the spawn function is generic, and you notice here we're passing like a tuple of 3 different types. We could remove some or add some. It's very generic. And then we create a schedule. And the schedule is what organizes our logic that's going to operate across all of our data. And this separation of data and the logic is really powerful because it means we could run the same schedule against multiple sets of data in parallel. We could also have different schedules that are do different things. So we could have a startup schedule that might query data from a database or load up something from disk just once at the start. That has a different set of systems that are running. And we might have another schedule that is persisting to disk every 10 seconds or something, and we only run it occasionally. So it gives us a lot of flexibility in how we want to structure logic. You can see here we've added our 3 systems and we've called chain on them. So this tells the scheduler these have to run one before the other in the order I've given them. If you don't do that, it's up to the scheduler how it wants to run them. And if you notice, we've done a lot of data processing, and scheduler, if you put systems in that don't mutably change the same components, can actually schedule them in parallel. And so we've got this sort of parallelized data processing system that we've not needed to write any lifetimes for, and we get all these nice query iterator interfaces and everything like that. So that's pretty cool, and a lot of hard work has gone into the ECS under the hood to make that possible. So this is cool, but it's sort of, it doesn't help you that much if you want to compose your logic and logic from another library. So there's a higher level concept in Bevy called a plugin. And really a plugin is just packaging this stuff up into an interface. So this is exactly the same code, except we create a plugin and we implement the plugin trait. And all it does is the same stuff. It's adding our setup function that will run once at the start and our other calculation functions that run as we go. And that main function at the top is all you need to run it. That's it. And this is really powerful because it allows us to plug in different components and different systems that run that we have no idea about when we wrote our original logic and components. So here, all I've done is brought in the Bevy render plugin. I've just added it in addition to my own plugin. And then when we spawn our objects into the world, in addition to the 3, the name and the scores we had before, we now include a physically based rendering bundle. So bundle is just a collection of components. And when we added that rendering plugin, it added its own systems that will look for these PBR bundles, and it will do some rendering based off it. So we've now spawned an object into our world. It has all our previous statistics and information, components, and it's got this rendering plugin, rendering bundle that have no idea about each other, but they just work together seamlessly associated with the same entity. And then we have a really simple rotate function that it just queries all of the positions of all of the shapes and the current score of the user on top of them. And we're just rotating the shape based on the speed of the current score. So as the score goes up, the rotation goes up, and as they get unlucky and the score goes down, the rotation slows down. Oh, it stops. And that's kind of all the code you need to do that. We can also do some more interesting things. So, for example, default plugins is sort of the Bevy hello world, let's get everything going. It's got audio, asset loading, decompression, rendering, all that stuff. And we can just include a library from crates.io. So in this case, we're including Bevy XPBD, extended position something, the physics plugin from that library. And then in addition to the PBR bundle we spawned before, we just put in a couple more components, the rigid body from the physics library and a collision shape so that it knows how to move it around and interact with other things. And we spawn a couple of them, one every so often. And physics just works. That's all we've had to do to integrate physics into our simulation. And so you can see it's really easy to stack these things on top of each other, and you don't have to go back and re-architect your existing logic when you bring in new functionality and new features. So you could be adding audio to this. Maybe when they hit the floor, it triggers an audio cue, and the physics system has no idea that the audio needs to run. It's all very decoupled. I'll come back to this. So yeah, the TLDR is the ECS encourages decoupled design and separating data and logic. You make your own plugins that implement these systems that have these logic that run in certain orders, and they sort of have a view into certain sets of data, like a lens into a certain set of data, and they ignore all data on the entity outside of that, which allows them to work together with other systems and other plugins. The ECS handles all of the data organization and lifetimes for you. So those archetypes at the start, as you add and remove components at runtime, which is part of the flexibility, it will reorganize these architects as needed. So if, for example, we had a player, Bob suddenly stopped playing, we could remove his current score component, and then the ECS would sort of do a little bit of bookkeeping and garbage collection, and it would move Bob out of the top archetype into a new archetype where it only had name and high score. And so it will rearrange itself so that at query time, it's always optimal. We're only iterating the things we need to iterate. What else we got? Also, the work that's gone on in the type system to sort of make this work, like being able to request to have a naked function, right? It's not in another struct, like there's nothing else going on here. It's a function with a parameter that's a query. For the ECS to sort of be given that, where are we? For you to pass in a function as an argument to another function, and then the ECS is able to figure out what can be scheduled on multi-threads by itself is really a huge ergonomic win because you don't have to worry about any of that stuff. Plugins give this seamless composability. I went over that. One of the most interesting factors about this is the user code that you write, the systems I've showed you. That's how the engine is implemented internally. So in that default plugins at the start that comes from Bevy itself, it is just a huge group of other plugins internally. A logging plugin, an asset loading plugin, a scene plugin. So all of the code you've sort of seen is how the engine is implemented internally. So there's this really cool system of if you've written some game code or logic in Bevy, you know how to write engine code, which is super good for contributors. And now you know how to write games in Rust. So I better see some of these talks next time from you about your games.
Anyone questions just that up first? Questions for just go front, so that makes sure that everybody the question goes in the organized way. So, like anyone, Thomas.
Do you have a question, Thomas?
I do have a question. So I've looked at Bevy like a couple of times, and I've always found it fascinating on like how it nicely decouples things. And I've always had this urge that I want to use it for something else other than games.
Yep.
But I've never quite like managed to. Do you have any experience of using Bevy ECS or any ECS outside of games?
Not very much personally. You could use it for example, if you had some kind of bulk process you need to run over a large set of data. But usually, it's in like a typical, a web server. It's a service like that is not constantly running logic over the same set of data. It's loading something up and doing it and putting it back. So it's not as applicable to all situations. However, I have seen people doing it for simulation stuff. For example, simulating like rotations of planets and needing to update those like as frequently as possible. It does provide a flexible way to do sort of simulation stuff like that.
Could I chip in there actually? I'm in the middle of trying to write a web framework using Bevy,
Nice.
just to see if you can basically. I actually started just bringing in the ECS because I was starting to get in a bit of a tangle with the lifetimes. And the ECS actually helped a lot with that. And then when I read more about Bevy and how you can actually query the ECS using the actual engine itself, thought give it a go. So I'll let you know how it goes. I think one of the problems I've had so far is dealing with async. The engine's not really kind of designed around async. It does have a facility for doing async tasks in the background and kind of letting frames iterate until you get to the point where those async tasks are done. But if you actually want to kind of hold up the world on async, then I think you got to take matters into your own hands a bit. But yeah, I'll let you know next month, I guess.
We'll talk about it next time.
Yeah, maybe.
Yeah, my question was, how do you make plugins talk to each other, third-party plugins talk to each other? For example, if you have your own positioning system and like some third-party physics engine and then another physics engine you want to sometimes put in, for example, like a planetary simulation or something. I don't know, so multiple plugins talking to each other.
Yeah, a good question. So there is, like you always have a sort of chicken and egg problem like that. However, a lot of the core Bevy libraries are relatively lightweight, and a lot of the third-party ecosystems sort of converge around using those as much as possible. So here I showed like, whoopsies. Here I showed when you add systems, there's like a word startup and a word update at the front. So these are like schedules that are defined in Bevy that all third-party systems can access. So for example, physics system will hook into a schedule called fixed update, not the regular update, and it'll run in a different cadence. And so there's all these things sort of set up ahead of time that the third parties can sort of work around and understand when certain things are going to run. So there is a layer that has to happen a little bit beforehand, but they all sort of build on top of their common ground.
The last question.
I'll just extend on that. Is it possible to use generics on plugins?
Yes, and yeah, they're just structs. So, and systems are just functions. You can use generics on them too. It's all, you know.
This last person.
Sure. Yeah, what I was wondering was with kind of this ECS behavior and everything being defined as components on your entities, do you still find much for use for traits?
Less, because things that you typically would put in a trait tend to end up as a system that operates on certain data. So when you sort of implement trait X for something, that's sort of like your system that has a query over X. They sort of are a little bit analogous. So I don't tend to find I need traits very often in Bevy. Yeah.
Yeah, cool.
Okay,
Thanks.
cool, awesome, thank you.
Thank you.